All right, so get this. You're scrolling through your favorite AI image generator. You're trying to create that perfect picture. You type in a cat sitting on a table facing left. The AI whirs and sputters and then proudly presents its masterpiece, a cat, floating 3 feet above the table, maybe facing. Who knows?
It's a common problem. Even cutting-edge AI, like GPT-4 and Gemini, can really struggle with something seemingly simple, figuring out which way things are facing in an image.
It's true. And that's exactly what we're diving into today. The fascinating world of object orientation and how AI is learning to crack this spatial code. We're going to explore a groundbreaking new approach called Orient Anything, based on some really cool research by Zihan Wang and their team.
What makes this research so fascinating is that orientation is crucial for AI to truly understand scenes and spatial relationships. Just like humans use orientation to navigate the world, AI needs that same spatial awareness to make sense of images.
So what's the big deal with orientation anyway? It seems pretty straightforward. Things face left, right, up, down. What am I missing?
You'd be surprised. The researchers actually put these AI superstars to the test with something called OriBench. It's like an obstacle course for orientation skills. And guess what? They found that even advanced systems like GPT-4 and Gemini tripped up on what seemed like basic tasks.
Like what? Give me an example.
Imagine you're looking at a picture of two people standing side by side. Could you tell me which one is on the left and which one is on the right? For you, it's probably effortless, right? But
Yeah.
for AI, it can be surprisingly difficult.
Wow. I never thought about it that way. So if something this simple is a challenge, why is it so hard for AI to get orientation right?
Part of the problem is that there's just not enough data out there that specifically focuses on orientation. Most image data sets label what objects are, like person, chair, table, but they rarely say which way those objects are facing. And manually labeling all that orientation data for every object in every image would be a massive undertaking.
It would be like trying to catalog every single leaf on a tree and which way it's pointing.
Exactly. So the researchers behind Orient Anything came up with a very clever solution. Use the power of 3D models to create their own treasure trove of orientation data.
Okay, so instead of trying to label real-world images, they built their own virtual world.
Precisely. They built this pipeline that automatically filters, annotates, and renders 3D models. It's like a 3D model factory churning out perfectly labeled data.
Walk me through that step by step. How do you turn a bunch of 3D models into orientation data gold?
They started with a huge database of 3D objects. First, they had to filter out any models that were wonky or tilted. They only wanted objects standing straight, like little soldiers at attention.
So they're starting with a clean slate.
Yeah.
No slouching allowed in this virtual boot camp.
Right. Then they had to figure out which way each of these 3D soldiers was facing. And here's where it gets really interesting. They used another AI, Gemini, to help with the labeling. They basically showed Gemini different views of each 3D object and asked, which one looks like the front?
AI training AI. That's wild.
It is. And once they had all these neatly labeled 3D models, they could start rendering, generating images of these objects from all sorts of random angles and viewpoints.
So they're essentially taking pictures of their 3D army from every possible direction.
Exactly. And because they knew exactly how the model was oriented in 3D space, they could label each image with precise orientation information. It's like having a cheat sheet for every image, telling you exactly which way things are facing.
Okay, so they've got this incredible data set of perfectly labeled images. But how does the Orient Anything model actually learn from all of this?
That's another brilliant part of their approach, instead of having the AI try to predict exact orientation angles, which can be tricky. They used probability distributions.
Probability distributions, that sounds a bit intimidating.
It's actually very intuitive. Imagine you're trying to guess which way a spinning top will land. You can't know for sure, but you can say it's more likely to fall pointing in one direction than another, right?
Yeah, that makes sense. So it's not about knowing exactly where it will land, but understanding the probabilities.
Exactly. And that's what the AI is doing with these probability distributions. It's like creating a heat map of possible orientations, with the hottest areas representing the most likely angles. This way, the model learns to consider a range of possibilities, which is much more robust and helps it deal with variations in how objects can appear in images.
So it's not just saying, this chair is facing exactly 30 degrees to the left. It's saying it's probably somewhere between 25 and 35 degrees. That seems a lot more realistic, considering how messy the real world can be.
You're absolutely right. But that brings us to another challenge, bridging the gap between these perfectly rendered images and the messy, unpredictable real world. A 3D model of a chair is always pristine. But in real life, that chair might be partially hidden behind a table or have someone sitting on it. or be lit in a strange way.
So how do they prepare this AI for the wild west of real-world images?
They used a few clever strategies. First, they didn't start the model from scratch. They initialized it with pre-trained knowledge from real-world images. It's like giving the AI a crash course in how objects actually look in the wild.
So they're not teaching it to recognize objects it already knows what a chair is. They're teaching it to understand how those objects are oriented in real-world environments.
Exactly. And the second strategy was to use data augmentation techniques. They basically made those rendered images more realistic by adding things like random cropping to simulate occlusion, like that chair hiding behind the table, and training the model to isolate objects in cluttered scenes, just like it would have to do in the real world.
Okay, so they built this amazing model, trained it on a mountain of data, and prepped it for the real world. But the big question is, does it actually work?
That's what we'll dive into next. We'll explore how well Orient anything performs on different tests, including its remarkable ability to figure out the orientation of objects it's never seen before.
All right, I'm hooked. Let's take a quick break, and then we'll unpack those results and see just how powerful this AI really is.
Welcome back to our deep dive into Orient Anything, where we're exploring how AI is learning to understand object orientation.
Before we get into those mind-blowing results you teased, I want to go back to those probability distributions for a second. I'm still wrapping my head around how that actually works in practice.
It's a clever way to address the inherent uncertainty in real-world images. Instead of forcing the AI to pinpoint a single orientation, which might be impossible with things like occlusion or perspective shifts, it lets the AI express its confidence level across a range of possibilities.
Okay, so give me a real-world example. Let's say we're looking at a picture of that cat on the table. Hopefully this time it's actually on the table.
Right. Instead of saying the cat is facing exactly 30 degrees to the left, the model might say there's a 70% probability the cat is facing between 25 and 35 degrees, a 20% probability it's between 35 and 40 degrees, and so on.
So it's like the AI is hedging its bets a little, which makes sense because in a photo, you can't always be 100% sure.
Exactly. And this approach is particularly useful when dealing with objects that are partially hidden or viewed from unusual angles. It allows the AI to say, I'm not entirely sure, but based on what I can see, here's what I think is most likely.
That's a much more nuanced way of thinking about orientation. It's not just about being right or wrong. It's about understanding the degrees of uncertainty.
Precisely. And this nuanced understanding is one of the key reasons Orient Anything can generalize to new objects and scenarios it hasn't seen before. It's not just memorizing orientations, it's learning the underlying principles of how orientation works in 3D space.
Okay, I'm starting to see the bigger picture here. But how do we know this actually works? How do the researchers measure the performance of a model like this? It's not as simple as saying, yep, the AI got the orientation right, or nope, it messed up.
You're right, it's more complex than that. They use a combination of quantitative metrics and qualitative visualizations to evaluate the model's performance.
So the numbers tell part of the story.
Yeah,
And the visuals help us understand what's really going on.
exactly. On the quantitative side, they compare the model's predicted orientation angles to ground truth annotations on benchmark datasets. They use metrics like absolute error, which measures how far off the AI's prediction is from the true orientation.
So it's like grading a test. How close did the AI get to the right answer?
Right. And they also look at accuracy within certain tolerances, like how often the AI gets the orientation within, say, plus or minus 5 degrees of the true value.
Makes sense. But what of the visualizations? How do those help us understand the AI's performance?
Visualizations are incredibly valuable because they give us a more intuitive grasp of how the model is working. Instead of just looking at numbers, we can actually see how the AI is perceiving the orientation of objects in different images.
So it's like peeking inside the AI's brain and seeing the world through its eyes.
Exactly. And the visualizations in this research are particularly compelling. They show Orient Anything accurately predicting the orientation of objects in all sorts of challenging scenarios. Video frames, multi-view images, even really cluttered scenes with lots of objects.
That's amazing. It's like the AI is developing a sense of spatial awareness that's almost human-like.
It really is. And one of the things that sets Orient Anything apart is its ability to perform well, even in zero-shot scenarios.
Right. You mentioned that before. It can figure out the orientation of objects it's never encountered before. But I have to admit, that still sounds like magic to me. How is that even possible?
It all comes down to the way the model learns. Remember those probability distributions. By training on a massive data set of 3D models rendered from countless angles, Orient Anything develops a deep understanding of the underlying geometric principles of orientation.
So it's not just memorizing what a chair looks like from different angles. It's learning the fundamental rules of how orientation works in 3 dimensions.
Exactly. And that's what allows it to generalize its knowledge to new objects and situations. It's like a child who learns the concepts of left and right and can then apply those concepts to any object, regardless of its shape, size, or color.
That's a great analogy. It's like the AI is learning the language of spatial relationships. But before we get too carried away, you mentioned earlier that the researchers did some special tests called ablation studies. Can you remind me what those are and why they're important?
Absolutely. Ablation studies are a crucial part of AI research. They're like controlled experiments where you carefully remove or alter different parts of the model
Mhm.
to see how it affects performance.
So they're basically saying,
Hmm.
what happens if we take this piece out? Does the AI still work as well?
Exactly. And by doing these ablation studies, they were able to pinpoint which design choices were most important for Orient Anything's success.
I'm curious, what were some of the key takeaways from these studies? What really makes this model tick?
One of the most significant findings was that providing the model with multiple views of an object during training, like seeing it from the front, side, and top, drastically improved its performance.
Makes sense. It's like getting a 360-degree view of something. You understand it much better than if you only see it from one angle.
Precisely. They also found that incorporating symmetry analysis was really helpful. This helped the AI distinguish between objects that have a clear front and back, like a car, and objects that are symmetrical, like a ball.
So they're teaching the AI to recognize not just the orientation, but also the inherent symmetry properties of objects.
And perhaps most importantly, the ablation studies confirmed that using those probability distributions was far superior to simpler approaches, like just trying to predict the exact orientation.
So all those clever design choices really paid off. But now I'm wondering, what can you actually DO with an AI that's this good at understanding orientation? It's cool that it can tell which way a chair is facing, but what are the real-world implications?
That's the exciting part, and that's what we'll explore in the next segment. We'll dive into some of the mind-blowing applications of Orient Anything, from improving AI image generation to revolutionizing how we interact with the world around us,
All right, I'm on the edge of my seat. Let's take another quick break.
and then jump into those applications. So we've been talking about Orient Anything and how it's teaching AI to understand which way things are facing in images.
And how that seemingly simple skill unlocks a whole new level of spatial understanding for AI.
But let's get down to brass tacks. What can you actually do with this technology?
Well, one of the most immediate applications is in the world of AI image generation. You know how sometimes those AI-generated images can look a bit off, like spatially impossible?
Yeah, you ask for a cat sitting on a table and the AI gives you a cat floating in midair, or a car parked sideways on a wall.
Exactly. Orient Anything can be used to score those generated images, making sure they actually adhere to the spatial conditions you give them. It's like having an AI art critic that can spot those subtle inconsistencies that make an image feel wrong.
So it's not just about making pretty pictures, it's about making pictures that actually make spatial sense. Right. And this could have a huge impact on fields like architecture, design, and even special effects in movies. Imagine being able to generate 3D models of buildings or movie scenes that are not just visually appealing, but also structurally sound and spatially realistic.
That's incredible. But it's not just about creating images, right?
Yeah,
This technology could also change the way AI interacts with the real world.
absolutely. The researchers found that combining Orient Anything with other AI systems, like object detectors and language models, allows AI to understand and reason about spatial relationships in a much more sophisticated way.
Can you give me an example?
Imagine you have an AI assistant that can not only identify objects in an image, but also understand their orientation and spatial relationships to each other. You could ask it questions like, from the perspective of this person in the image, is that object to their left or right? Or is the chair facing the table? And it could give you accurate answers based on its spatial understanding of the scene.
Wow. That's like giving AI the ability to see the world through someone else's eyes.
Exactly. And this kind of spatial reasoning could have a huge impact on fields like robotics and autonomous navigation. Imagine robots that can navigate complex environments, understand spatial instructions, and even assist people with tasks that require spatial awareness.
I'm starting to see how this technology could be a real game changer. What other applications are you excited about?
Well, another area with huge potential is 3D modeling. Right now, a lot of 3D models have inconsistent orientations. Some are tilted, some are facing the wrong way, which can cause problems when you're trying to use them in things like virtual reality or gaming.
Yeah. I can see that would be frustrating. You're trying to build a realistic virtual world and all your objects are pointing in random directions.
Exactly. But Orient Anything can actually be used to automatically correct the orientation of 3D models. It can analyze images of the model from multiple viewpoints and determine the most likely orientation based on its knowledge of real-world object placement. It's like having an AI orientation expert that can come in and tidy up all your messy 3D models.
So it's not just about understanding orientation in existing images. It can actually be used to improve the quality and consistency of 3D models themselves. That's amazing.
It is. And of course, we can't forget about augmented reality. Imagine wearing AR glasses that can not only overlay digital objects onto the real world, but can also understand the orientation and position of those objects in relation to your surroundings.
Okay, now you're talking my language. That sounds like something straight out of a sci-fi movie.
It does, doesn't it? But with Orient Anything, this kind of seamless integration between the digital and physical worlds is becoming increasingly possible. You could have AR applications that guide you through complex assembly tasks, provide real-time spatial information about your environment, or even create interactive games that blend seamlessly with your surroundings.
This is mind-blowing. We've gone from talking about chairs facing the wrong way to potentially revolutionizing how we interact with the world around us.
It's a testament to the power of fundamental research. Like, who would have thought that teaching AI to understand which way things are facing could unlock so many possibilities?
It really highlights how interconnected different areas of AI research are. A breakthrough in one area can have ripple effects across multiple fields.
Exactly. And this is just the beginning. As AI continues to evolve and deepen its understanding of the world, who knows what other amazing applications we'll discover?
It feels like we've only just scratched the surface of what's possible. It's an exciting time to be following the world of AI.
It certainly is. And we hope this deep dive has given you a glimpse into the incredible potential of this technology. We've explored the technical details, the challenges, and the mind-blowing applications.
If you're as fascinated by Orient Anything as we are, we've included links to the research paper and some really cool visualizations in the show notes. Be sure to check them out.
And until next time, keep exploring, keep questioning, and keep diving deep.